In this video, we're going to solve a quadratic inequality word problem. So let's start by reading through this word problem together. It says a rectangular parking lot must have an area of 8,000 square feet or more. And then it says the area of the parking lot can be found using the following equation. So this equation is going to represent our area, and we know that our area has to be 8,000 square feet or more. So the instructions start by asking us to write an inequality to represent this situation. Well, the first thing we know is that we're going to be putting 8,000 square feet in for area. So we have 8,000, and it is somehow related with an inequality to the length times 220 minus length. So notice how I took this piece, it's still the same, and I replaced area with the 8,000. Now what we have to think about is which way this inequality is going to face. And remember, this on the right-hand side is our area of our parking lot. That is how we calculate our area. And our area needs to be 8,000 square feet or more, which means it can be equal to, or it has to be bigger than, 8,000 square feet. So notice that our area, which is represented by this expression, is bigger than or equal to 8,000. So now that I've set up my inequality, we can now move forward and solve it. And remember that we start solving a quadratic inequality by treating it like an equation to find those key values where we're going to be able to write inequalities for our situation. So here we have 8,000 is equal to L times 220 minus L. And in order to treat this like a quadratic, I need to start by getting rid of those parentheses. So I distribute and I have 8,000 equals 220L minus L squared. And while I could subtract the 8,000 over here, I like to keep my squareds positive when I can. So I'm going to start by adding L squared and subtracting 220L from each side. And again, you can just subtract the 8,000 over if you would like. This is just what I prefer. So I have L squared minus 220L plus 8,000 is equal to 0. And then from here you have to decide which quadratic solving strategy you want to use, so completing the square, factoring with the ABC method, quadratic formula. I'm going to choose here to use the quadratic formula just because some of the numbers are so large. So I start with x equals opposite b plus or minus the square root of negative 220 squared minus 4 times a times c all over 2 times a. Then if we simplify what's underneath the square root, we end up with 220 plus or minus 16400 over 2. And if we square root that, we end up with 220 plus or minus 128.06 all divided by 2. So we can use this to help us find our possible x values here. So remember, one option is we take 220 and we add 128.06 and divide it by 2. And the other option is we take 220 and we subtract 128.06 and we divide it by 2. If we complete the first one, we end up with about 174.03. And if we simplify the second one, we end up with 45.97. So those are our two key values on our number line. So we have 45.97 down here and 174.03 here. Now because we have an equal to here, we know that we have a closed circle at each, and then we can see that we have regions 1, 2, and 3. So if we pick a point in the first region, we find x is equal to 0. So that's the first point I'm going to pick, and if I substitute that into my equations, I have 8,000 is less than or equal to 0 times 220 minus 0, which is going to turn into 8,000 is less than or equal to 0, which is false. So I know that this first region is false. If I pick a number in my second region, I can pick something like x is equal to 50. So I have 8,000 is less than or equal to 50 times 220 minus 50. And if we simplify that, we get 8,000 is less than or equal to 8,500, which I know to be true. So I know that region 2 is in fact true. And then if I look at region 3, if I pick a number in there, I can pick x is equal to, let's say, 200. So if we substitute values in there, we get 8,000 is less than or equal to 200 times 220 minus 200. Sorry, I'm running out of room there. But if I multiply that out, I get 8,000 is less than or equal to 4,000, which I know to be false. So what I'm noticing here is that region 3 doesn't work, region 2 doesn't work, but it's only this region right here in the middle, which is region 2, that results in lengths that will produce the area that we need in order to create our parking lot. So if I make a second number line here, so I have 45.97, 174.03, and I have my closed circles there, I can connect them. And what I know as a result of this number line is that my length value for my rectangle, for my parking lot, is going to be less than 174.03 feet, but more than 45.97 feet. So as long as the length of my parking lot is between these values of 45.97 and 174.03, as long as the length falls in there, I will have an area of my rectangular parking lot that is 8,000 square feet or more.